This is LeetCode problem 15, 3-sum. Before you watch this video, please watch LeetCode problem 167, 2-sum 2 first. I will put the link below. If you know the solution to 2-sum 2, 3-sum question is very straightforward. Now, let's get into this question. Given an integer array numbers, return all triplets, nums I, nums j, nums k, such that I now equal to j, I now equal to k, and j now equal to k, and nums I plus nums j plus nums k equal to 0. Notice, solution set must now contain duplicate triplets. In example 1, we have an array of numbers -1, 0, 1, 2, -1, -4. -1 plus 0 plus 1 equal to 0. 0 plus 1 plus -1 equal to 0, as you can see here. Eventually, those two are the same array, which are -1, 0, and 1. That's why we only return one triplet in the output. Other than that, we also have -1 plus 2 plus -1 equal to 0. That's why we also have another triplet, -1, -1, 2, in the output. Let's look at one example. We have an array of 0, 3, 4, -3, -2. Two-pointer technique will be a very good solution for this problem. In order to use two-pointer technique, we need to sort the array first. Then that will be -3, -2, 0, 3, 4. Given we need to find the triplet, which is A plus B plus C equal to 0, and then we return array of A, B, C. So now let's see, -3 is A, and then now we need to find the pair B and C. If they equal to -A, then A plus B plus C will equal to 0. So in this example, now A is -3, so we need to find B plus C equal to 3. Now let's use two-pointer technique. Left pointer point to -2, right pointer point to 4. Let's sum them up. -2 plus 4 equal to 2, which is less than 3. Then we need to move the left pointer to get a larger sum. Then we sum it up again. 0 plus 4 equals to 4. Now it's greater than 3. Then we need to move the right pointer. Then we sum them up again. 0 plus 3 equal to 3. So now we get 3. And then we can return the output, which will be -3, 0, and 3. Let's see another example here. We point A to -3, and then using two-pointer technique, we get -3, 0, and 3 as one triplet sum to 0. Now we move A to next value, which will be -3. So now we see we have duplicate A's. Then what should we do? We should move A to the next number, which will be -2, and skip the one has duplicates. Now we keep going. A is equal to -2, so we need to find B plus C equals to 2. Let's say B is equal to 0 right now. and then we find C 2 here, so that B plus C equal to 2. Then we keep going. So B move to the next number, and then we see we have duplicate B's. They are both 0. Then in this case, we use the same method, which is skip the duplicate B, move to the next one. Now, let's code it up. First, we initiate an empty list for the result, and then we sort the array of nums, n equal to length of nums. For I in range n, we need to avoid duplicate a value. If I is greater than 0, it means this is not the first number in the array. Nums I equal to nums I minus 1. It means those two are duplicates. We don't want to use same value twice. So we continue to the next iteration of the loop. Then we use two-pointer technique. We initiate left pointer, right pointer as I plus 1, n minus 1. Before left pointer meet the right pointer, total equals to nums I plus nums left plus nums right. If total is less than 0, then we increment the left pointer. If total is greater than 0, we need to decrement the right pointer. If total is equal to 0, that means we find our result. We should append nums I, nums left, nums right to our result list. So now we have value A, value B, value C equals to 0. We still have the same A value, but we need to find the next B value. So we shift left pointer to the next number by using left plus equal to 1. We also need to avoid duplicate B values. While nums left equals to nums left minus 1, it means those two are duplicate B values. We just need to skip the duplicate value and go to next one by using left plus equal to 1. Finally, we return the result. This is a summary of how we solve the problem. One thing I want to call out is we handled duplicate A values, we handled duplicate B values, but we did not handle the duplicate C values. It's because C is determined by the equation C equal to minus A plus B. Each unique A-B pair will result in a unique C value. For time complexity, it's O n squared, and for space complexity, it's O of n, due to space taken up by Python's sorting algorithm.